All right, guys, we're going to look at this final video here, working through this lesson on the binomial theorem. Um, again, I rewrote the binomial theorem right here on the page. It's on the first page of the PDF we've been working through, but it's going to help on these last three problems. And these last three problems deal with finding specific terms. Like if you look at this 13I minus 4 to the fifth, that would involve taking 6 terms and combining them. But we're going to take a shortcut here and just kind of look at the theorem itself. If you look at the binomial theorem, the third term over, right, if I count 1, 2, 3, is this one here. It's n choose 2 is the binomial coefficient. Of course, n is the power. So the third term over would be the power of 5, right? Choose 2, which is this number is 3. It's always 1 less on the bottom, just the way it shakes out. And then the way I remember it is that, I'm going to write I to a power and minus 4 to a power. And whatever that 2 is would go here. It actually goes with the second term. That's just the way, if you kind of look at the binomial theorem, that bottom number ends up being the power of the second term of the binomial. And then to get the first term, you just subtract it. If it's 5th degree, right? If it's 5th degree and I already have a 2 there, then I need to have a 3. Oops, sorry, didn't mean to do that green. And that's the answer. I just kind of have to get the numbers. 5 choose 2, either by Pascal's triangle or the formula for combinations, or your calculator is 10. It just so happens 5 times 2 multiplies to 10. It's just a coincidence. I cubed is negative I using the powers of I, and then 4 squared is 16. So if I multiply that, I get negative 160I. Okay. All right. Let's look at a couple more of these. What if I kind of expanded 2a minus 6b to the 11th? If I did that, I'd actually get 12 terms. It would be disgusting. It would take me a long time, even with the binomial theorem. But they're saying, hey, we just want one of the terms, the second term. And so what do I need? I need a binomial coefficient, which is 11 choose. Second term over, since we start with 11 choose 0, the second term over is 11 choose 1, or it's one number less than the term. I'm going to have 2a to a power and minus 6b to a power. And the way I remember it is the number on the bottom goes with the second term, and then if you subtract 11 minus 1 is 10, that goes with the first term. And then it's a matter of just doing some calculation. Anything choose 1 is just the number. So 11 choose 1 is 11. And then I have 2 to the 10th, which is 1024, a to the 10th. And then negative 6 to the first, of course, is negative 6. And b to the first is b. So that's a 6 and that's a b. If I multiply those, of course, those numbers are huge, but I'll get a negative 67,584. Again, why is the number so big? Because it was the 11th power. Once your powers get big, your coefficients are just going to automatically get big. But the powers are pretty easy, a to the 10th b. And you'll see that if it's the 11th power, you're, no matter what term you are, not the coefficients, the variables, the powers have to add up to 11. And here we go, 10 and b to the first is 1. So 10 and 1 is 11. So that would be the second term of what would be a ridiculous polynomial if you multiplied the whole thing out. And 15 actually, kind of working backwards. They're saying, what would be the binomial coefficient of that term, a to the second, b to the 19th, if I expanded a plus b to the 21st? Well, n, or the degree, is always the top number, And then the bottom number, actually, it doesn't matter. You could say 19, but you could also say 2. It really, either one, these are both the same number. Either 21 choose 19 or 21 choose 2. It really doesn't matter. You'll get the same number either way. Well, how can I do this? Let's write out what this is. 21 factorial over 2 factorial, and then the difference factorial. I think you see why it doesn't matter. Either way, you're going to get a 2 and a 19 on the bottom when you subtract 21 minus 2 or 21 minus 19. And then again, these guys cancel out, right? I get 21 times 20, and then I get 19, 18, 17, 16, but that cancels out with the 19 factorial on the bottom. And then 2 factorial is just 2. And you can actually do a little canceling, can't you? 2 and a 20, 10 times. And then if you multiply across, this is 210. So that would be the binomial coefficient for what the a squared b to the 19th term. Okay, hope that helped. Again, you got 5 videos here, some tougher than others about the binomial theorem. Just watching them won't help. Hopefully you're watching them with a paper and pencil and kind of working through and pausing and rewinding as is necessary. But you'll get it. Stick with it. You can do this. All right, guys, I hope that was helpful. Take care.